Hello everyone. I'm here with another J mains question, and this question was asked on 2nd of Jan 2025 in the second shift. Okay, so as you can see, this question is based on the current electricity and the capacitor uh, chapter here. So what we have in front of us is an RC circuit. So we're gonna so we have to find out the value of I here. Okay, so the important point here is the value of I, as you can see. Now here we have a capacitor. Okay, now in the RC circuit shown, find I. So how to figure out I? Now see, in the circuit we have a resistors, a battery, and a single capacitor somewhere here. So see, here it's not mentioned that the I is to be found in the steady state. Okay, so here we are going to assume that the question had asked you, because after a certain amount of time the capacitor stops conducting, or the current cannot flow through this branch. Okay, so this become obsolete. Is it clear? The capacitor in the steady state will not allow the current to pass through here. Now in this branch there will not be any current, so this branch becomes obsolete. It means this has to be removed. Now if this gets removed, this part, then what we are left with? So if you can see here, we are left with this R, and here we have another resistance, and R, this is your voltage, and this is another. So just let's draw it quickly. So now we're gonna work on the remaining resistors. Okay, the remaining part of the circuit is something like this, and there will be further rephrasing. Now okay, so this part become obsolete because after a sufficient amount of time the current through this wire is going to be zero because of the capacitor. In steady state, this is what happens. Okay, I think we have done it wrongly. Okay, it's not wrong, but I think we should follow whatever is mentioned here. Now all these resistors are R. So let's draw them first. So here, now this is at steady state. Okay, now this circuit is under the steady state. Okay, steady state condition. Okay, we are supposed to remove here this one. Now how much is this? Now see here, in this part there is only one path. If the current goes like this, so if it distributes, it cannot come back. There's no second path here. Like in the case of circuit, if you look at the circuit, we have a complete path. If the current flows like this, it comes back. It's not it, and it forms a complete. Now here, if the current goes like this, suppose I1 and here I2, now there's only one path here. Okay, it cannot go as well as come through the same path. Okay, so this has to be removed. Now we are going to remove this part. So what we're left with is only this much. Now this is also obsolete, it's of no use. Let's see, remove this one. Now what is left is just this much. The remaining circuit is something like this. Now this is quite easy to solve. If you look at this, now this is what we are left with. Okay, now this is R, and this is R. So if you collect these terms, now see the potential here. This whole part is in series. Okay, now so how much is the the equivalent resistance for these two, it's 2R. Now this 2R, if you go further and club these whole thing, then this R and 2R is in parallel connection. So what is the R equivalent for this one? It will be 1 by 2R plus 1 by R, or you can simply write it down as for this part, it's gonna be 2R into R divided by 2R plus R. So this is gonna be 2 by 3R. Okay, this is the R equivalent for this one. Now I'm gonna rephrase it further so that we don't miss the required information here. So we have now this part, and this part is 2 by 3R. So I'm going to put 2 by 3R here, and this is R, still it is R, and this resistance will be R, and here we have R, and this is the battery. So R. Now how much is this combination? This combination is 5R by 3, because they're in series combination. They're in series. Why? Look at the potential here. This is just one part. So this 5R by 3 and this R, they are in parallel connection. Okay, so let's club them now. Parallel connection. This here in parallel. Okay. So how much is this now? The equivalent of these two will be 5R by 3 into R divided by 5R by 3 plus R. Okay, we know the formula for parallel connection, R1 R2, or we call it R1 R2 divided by R1 plus R2. So following this rule, I'm just writing this down. So this will be how much? Now just this will be R and R will get cancelled. So here we have 8 and here we have 5. So it will be 5 by 8R. Okay. Now this 5 by 8R and this R is connected in. So now finally what we are left with is this a resistance of 5R by 8, and this is another resistance. So both are in series connection. Okay, so the final R equivalent is gonna be, just add them up. So we are left with 13R by 8. Okay, now how much is the current? So current, since the voltage is, how much is the voltage given in the figure? V. V is the voltage. Okay, so if the voltage is V, so current will be V divided by 13R by 8. So this is 8V by 13R. Now this is your answer. So okay, now you can see that the option which is matching is option number 3. Okay, we have the third option as our answer, 8V by 3R. Let me, I think I click that. Now this is your answer. Okay, 8V by 3R. So can you give your feedback? So whatever you feel like, if you're like, okay, if the content helped you in any way, just kindly like the video and share it. Sharing is caring. Okay, so follow this mantra and share things which are kind of beneficial for others. Okay, see you, bye.